Okay, I'm live with Assimilate-Rust here, and I'm going to be doing some stuff that's actually pretty cool. One of the things I'm going to show you today is how to actually code up AWS Lambda plus EFS solutions, right? So here we see that I have a Lambda EFS that I've got set up here. And this really opens up a whole new world when you can use the Elastic file system to actually build solutions. And one of the things that I like to do is actually use Cloud9 as the place that I actually work with the EFS. So I'm going to go over here first, and I'm going to go to Cloud9. Next up, what I'm going to do is that I can go back to my Cloud9 environment here. Here we go. And I don't think I have any environments active. Yeah, so I don't. So this will be good, is I'm going to show how to actually work with your environment. So let's go ahead and do this, create an environment, and we'll call this Rust EFS. Lambda, Rust EFS Lambda. Next up, we'll just say, mount EFS so I can develop for Lambda. Now, in terms of an instance, probably you want something that's a little bit beefy, just because you're going to be compiling code. So I'm going to pick a large, and then I'm going to go ahead and say create. Now, as this thing is opening up, I'm going to have another environment open. So I'm going to kind of go back and forth here, in that I also will go to this Rust MLOps template project that I have set up here, and I'm going to launch this workspace, right? And so here we go. We've got this thing cooking. Now, one thing I also probably want to do is I made a change to go to the latest version of Rust previously, and I think I'm going to do that again. So I might just make that change here, is that in the Docker file, I want to go to latest, I believe. So we'll check that out in a second. So we have this one opening up. Uh-oh. Wow, it's not available. That's weird. I haven't seen that one happen before. Well, let's create a new one. And we'll do Rust EFS Lambda 2 and mount EFS, and we're going to say maybe slightly bigger, like a C5. There we go. Hopefully this one works. Okay, so while this thing's cooking, we can go back here. Now, this is what I wanted to check out in this other environment. I mean, it probably doesn't matter for today, but inside of dev container, Docker file, see, I think we want to change this to latest. Latest. There we go. And so I want to add this, git add, dev container, adding latest. We'll push this, git pull, and then we'll push this change. And this just gives me that, so that basically I can rebuild, full rebuild container, so that I can get the latest version of Rust in case there's issues with, writing Rust against AWS Lambda. But basically, we got this thing rebuilding. Wow, this one's not available. Holy smokes! Choose. I've never seen this before with Lambda. Very, very strange. Well, what we could do is try a different region, maybe. Let's go to Ohio. And wow, That's crazy. I have a bunch of environments that I forgot I have set up in Ohio. So I should probably clean those up at some point. Do I have any reads nope, don't have any in there. But yeah, let's try it. Let's try Ohio. Maybe U.S. East. There's some issues um, going on here. But again, we'll go to create environments. We'll look at environments. And you see I have a bunch of environments here. In fact, we can just say create new, and we'll say EFS lambda. Although, now this could cause a problem because now I need this in US East, which is unfortunate in that, you know what we could do is I could just double check EC2 instances, launch instance, Amazon Linux, free tier available. I wonder if we can tell basically if we go to spot instances, maybe. Well, yeah, this is a weird bug that I've never seen before. Because if I look here, this file system, we see that it's in US East, and so I do want my Cloud9 there as well. So let's try one more time. Let's try Cloud9, and let's stay in Virginia, and we can just say, for example, EFS one more time, and we can try. How about a small? With a small work? Hopefully the small will work. And while this is going on, hopefully it doesn't blow up, that I can take a look. Uh-oh. So I may have caused an issue by going to Rust latest. So let's look at dev containers real quick. Let's just double check I grabbed the right one. Let's say find Rust. Okay. Rust full. Yeah, so it should be this. Rust latest. And if I go back to this, VS, that looks correct to me. So I don't know why there's a bug here, unless I look at the this error here, and we look at view creation log. We can see what's going on. So we go to the bottom. Container started. Looks, Docker. An error setting up that container. Well, maybe I go back to what I had before, which is if I go to this other, maybe I was getting too fancy here. And if we go to Docker file and we look at the latest commit, we can just change this back to what it was before. I don't know why that was causing problems. This should work. There we go. Rust 01 bullseye. We'll go get status. Get add dev container. Adding latest. Revert. Push. Full rebuild container. Okay. All right, so we got that one going. Wow, isn't available in the requested. So EFS may not be an option for today then, which is very strange. I don't know why it's telling me that the environment is unavailable in the requested zone. So what we can do instead is not do EFS, and I'll wait for this thing to rebuild. And what I'll do is actually get just a regular Lambda going. So let's take a look at Lambda then instead, because this might be a better one to take a look at. Is that I can show one that did get EFS cooking, which is this one. So this Onyx EFS Lambda. And you can see the way it got hooked up, which is if we go to configuration here, there's two things that I did to it. One is I added LD library path. And what's cool about this is that this allows me to actually put shared objects inside of the EFS mount point. So when the Lambda is invoked, it actually can look at those shared objects and actually load them in. So that is actually pretty cool. And then the other thing I did was under file system here, right here, if we take a look at that, look what I did is I mounted that file system right here. So in theory, I could recreate this actually. That might be one thing I could do just because the Cloud9 is having issues. So if I wait for this thing to rebuild here, looks like it's going to be successful. Then I can just do everything from only inside of GitHub code spaces. The only reason I wanted this environment to have Cloud9 is so that I could mount the file system and put things inside of there. But I don't necessarily need to use Cloud9 for that because of the fact that I already have one working, right here. And we can just take a look at the code. So hopefully this opens up pretty quick here. And then I can just build a Lambda that communicates back and forth. We can even look actually at the code that I'll show you, which is the Onyx. So if we go to Onyx EFS, let's just look through this real quick. So the way this thing works is, see this, it's actually been able to invoke this endpoint, and I actually can go here to test, and because the payload doesn't do anything, I can actually test it out. And you should see if EFS, yeah. So it's actually working. It's actually doing an Onyx inference. So just to explain to you real quick what Onyx is, if we go to Onyx, it's a way to an open standard for MLOps, and you can see here that you have the ability to run things a lot faster. And in particular, one of the things that you can do is if we look at maybe the introduction here, you can look at some of the core concepts. And in a nutshell, we can also look at Onyx, the source code, Onyx GitHub. And what I was able to do here was to use this to do inference. Now, notice one of the things that they did recently is if we say Onyx community, is that where it was? Onyx Rust. There is Microsoft. There's another repo here. Where did they put this? Onyx runtime. Here we go. Right. So if you look at the runtime, you can see the different languages, but they also support Rust. So if we go back here, it looks like this thing is about done, and it's about to wake up. It's taken a while, but basically Onyx allows you to have a more performance invocation of a model, and there's a bunch of different examples of how to do this. And again, I can just do a very fast inference, and you can see here that this is doing machine learning in a tiny container or a tiny lambda, there is no container. It's just a binary deploy, and it was using 49 megabytes of memory. We were billed for 966 milliseconds, but it did computer vision, right? It did a computer vision inference inside of here. And so now that I'm back inside, we can take a look at that project. Let me cd into it. So we'll say cd into Onyx EFS Lambda. And if we go to it here, let's take a look at the code. So in the lib, what we do is I use Onyx runtime here, which is this, and then I have a run it method that's going to be exposed to the outside world. This run it method is later used with only one thread. I am actually kind of curious why you would do multi-threads. Like, I'm not 100% sure what this would get you, but there must be some reason someone would want to do a multi-threaded session. But in this particular scenario, we would load it from the disk, and look what it is doing. It's loading it from EFS, right? And then I go through here and I create a shape. I initialize the data here, and then finally I do the inference. So I do session run, and then I figure out the scoring. And then to run it, we just go through here. We go to the main, and you can just see like the general way a Lambda works is we have the Lambda runtime. We have like a struct that I'm going to use as the event that gets pushed in. We have the response back, which is this, and the scores is a vector of F32s. And then I actually build this little helper function just for like debugging. So what this helper function does is it lists the files inside of EFS. So you can see here that it's mounting the EFS, and it's basically saying for everything inside of there, just print it out so that I can take a look at it. And then in this particular scenario, this is where I have the handler. It takes in a Lambda event, which again does nothing, right? But we list the files here, and then now do I print the files out? You know what? I could change this code actually. Let's do that. Let's change the code to print, because when I invoke this, right? Oh no, it does. It does say files. There we go. So yeah, it puts the files in the payload that returns. So we can see all the files that are inside of EFS. We have the SO, right? The shared object. We have just like a file I put to play around. We have the Onyx models. We have a couple different ones here. And then I, of course, return back the scores here. So to run this, what I do instead of cargo is I have the Onyx runtime, which gives me the ability to use Onyx. I also have the Lambda runtime here as well, and I use Tokyo because that's part of the AWS SDK. It's an async SDK. And then in terms of the makefile, this is something that's pretty cool. Is in order to build this out. So let's just change it a little bit. Let's go through here, and we'll just say something like let's print out a test message of hello. Right. So we can say print. I think for Lambda, it typically will say, and for, I think it would be println, if I remember correctly, hello for the Lambda function. There we go. And so let's just double check that works. And now what I would typically do is I would say make, let's go back to the Makefile. So I would say make formats first. So make formats, format the code. Oh, I forgot to add a semicolon, which it's my Python background. It's making me write bad code. And then I do make lints. Right, so I think this is, ooh, whoa. This is, everything blew up here. What is this? Wow, make lints, linking with CC failed. Could not compile due to previous error. Let's do, this looks like a weird rebuild issue maybe. So I think we could say cargo clean maybe. And then we could say make lint. Maybe it got corrupted or something. I don't know. But in theory, the clean should, smoke out that issue, delete all of the artifacts, and then recompile it. You can see here that it's definitely saturating the box when it's rebuilding things. And we can even look at a htop here. Okay, so now we're back. Okay, so print not a function because I'm probably what is a print out. I always forget Rust prints. What am I screwing up here? I thought it was println. Yeah, what is this? What do you mean not a function? I think I did it right? So we'll go back here. Let's just put this in there. Println. We can say println. Let's do this. Make format. Make lint. I don't. I must have had some kind of typo. That's just weird. Rewrite as raw string. Sure. Let's make lint again. Right. So this is what I typically do. Go back and forth. If it's linting, that's a great sign. Then I like to do the release here. So this will actually build it. So we'll say make release. What? Oh, because I need to source the Python virtual environment. So we'll go through here and we'll say venv, right? Because it does, unfortunately, you need to install the cargo lambda. So we'll just say, basically Python 3-m venv. So make a virtual environment. Source the virtual environments. Activate. And then we do pip install cargo lambda like that. So this just allows us to basically have a special version of cargo that can do all this fancy stuff. There we go. And then if we say make release, we're good to go. It's going to go through. It's going to build it. Yeah, it's been a weird day, actually. All kinds of services have been breaking. I don't know if there's something going on with US East, Amazon, but there was an issue there. So once we do the build, then to deploy, we just do make deploy, which will run cargo lambda deploy. And then to invoke, I can just go through here and just send in a payload. So I don't even have to go to the console to invoke it. And again, if you remember, while this thing's compiling, that this thing actually, we've been able to configure it so that it's using the file system, right? Which is really a slick tool for Rust. Okay, ooh, that's not good. We have another error here, and it says Oh, failed to download runtime. Boy, this is like the boogeyman of all days here. What do you mean failed to download? Did they change it? Maybe they changed it. Onyx runtime. Huh. Let's try one more time. Yeah, failed to download is a weird one. There may be some outages on the internet. Well, there we go. So now it worked. And then we can go to the deploy. So we'll say make deploy. Here we go. You can see it's trivial. And obviously I have my API key set up. And then check this out. To invoke it, I just say make invoke. Boom. There we go. And look, hello Onyx. And that's the message that went in. And then if we go back to the Lambda itself and we go to the code, we should be able to test it ourselves here. So let's test it again. This is the new one. And we see everything that went on in there. Look, there we go. That's the new message that went in, right? Hello Lambda. Because if we go back to the code, we see, look, hello Lambda, right? So it's actually a reasonable scenario here to build out things that use the Elastic file system. You can see it's not too bad. And the deploy was actually pretty easy. So hopefully that's helpful to some people that want to play around with Rust and do it with AWS Lambda and EFS. All right, that's a good place for me to leave it off for today. All right, see you soon.